This video is on linear equations and slope-intercept form. These will be equations from a verbal description and graphs. Example A says a cab company charges $3 upon entry and 50 cents each mile. The cost for the cab ride C depends on the total miles M. A says write a now-next rule showing how cost changes with each additional mile. So a now-next rule utilizes what we have now to figure out what the cost will be next. So right now, we know that the cost is $3 because it says that a cab company automatically charges that amount upon entry. So this $3 upon entry tells us that it is the start. Then it tells us it's 50 cents each mile. That is our rate of change. So each mile we have to pay another 50 cents. The cost of the cab ride C depends on the total miles M. And as we remember, independent dependent, that Y depends on X. So the C value is actually going to be your Y. So if we're going to write slope-intercept form, it'll be Y equals. That means that the cost will be our C equals. So we'll have C depends on total miles M. These are our variables we will use. So write a now next rule showing how cost changes with each mile, each additional mile. So what we have now is what we'll use to get our next. Well, our value will be our next. Our answer is our next. So it will be next equals, because what are we getting next? Our next is whatever we have currently, now. Now, this is not going to be the $3 right now. It's saying whatever we have now. So this could be down the road after we've done 10 miles. How much is the next mile going to cost? So what we do is say next equals now. So whatever we have now, what's going to happen to the value we have now? Well, every mile, we are adding an additional 50 cents. So we would say plus an additional 50 cents. That's how we get the next number. But you do need to know what it starts at because we need to know what our current now is. So we would say starting at and the value that it started at. So our original start value was $3. This is our now next rule. So our next mile will cost $3 plus 50 cents. That's $3.50. Well, then the next mile will be what we have now is $3.50 plus 50 cents, which is $4. The next mile will be $4 plus 50 cents. Then the next will be $4.50 plus 50 cents. That's what the next now does. So it tells you how to create the pattern of numbers. So the equation we're going to find. Again, it goes back to C depends. That means your Y is your C value. So we would put C equals. Your cost is equal to the total amount of miles that we're going plus whatever the amount started with. It will be 50 cents each mile. That is your rate of change. That is your slope. So 50 cents. So Y equals MX, which in this case it's our letter M, because that's the variable we have to use, plus B. Remember, we are doing this in slope-intercept form. So this is the same thing as saying Y equals MX plus B. Well, B is your y-intercept value. That's your starting value. And in this case, we started at $3. So we would have a positive $3. So our equation in slope-intercept form is C equals 0.50 M plus $3. So if we did this, if we went 0 miles, we would do 50 cents times 0, which is 0, plus $3. My original cost is $3, which is what it said. Then if I went 1 mile down the road, I would do 1 times 50 cents, which is 50 cents, and I'd add that to $3. And my 1 mile would be $3.50, which is, if we follow the pattern, I would be adding 50 cents for each mile we go. So this equation holds true. Example 9 says a plane left Chicago at 8 a.m. and at 1 p.m. the plane landed 1,500 miles away in Los Angeles. We are told times, but we are not told the rate. We're not told per or each. So we do need to find the slope and the y-intercept, because again, we will be using slope-intercept form. So information, a plane left Chicago at 8 a.m. This is the time that it started at. So it starts at 0. Because the plane will land 1,500 miles away in Los Angeles. So that's the distance. So on here we need to find the rate, our rate of change. We have time and distance. Our rate will be, our independent will be the amount of time, and then our dependent variable is how far away. So that would be our miles. Our first coordinate, time is at 8 a.m. and our miles would be at 0 because they have not left. Our second coordinate would be at 1 p.m. and now the miles is 1,500 or 1,500. Those are our two coordinates we have. Now we're going to do our rate of change, which is change in y over change in x. Change in y will be from 0 miles to 1,500 miles, which is a positive 1,500 miles. Divided by change in x will be 8 a.m. until 1 p.m., which 8, 9, 10, 11, 12, 1 o'clock is 5 hours. So it would be 5 plus 5 hours. So if we were to simplify this, 1,500 miles divided by 5 hours is 300 miles per hour. That is how fast the plane is traveling. Knowing what our rate is and knowing what our start is, now we can find equations. The first part says write a now-next rule showing how the distance the plane is from Chicago changes after each hour. That's telling us that the distance, again, was the dependent. A now-next rule always says next is equal to our now, and then whatever we do to our now. So whatever we're at right now, it is saying the distance is changing. So every hour, it will change by 300 miles because it was 300 miles per 1 hour. So whatever we're at now, we're going to add 300 miles. But we have to know where it starts at. So we started at 0 miles. So our next is equal to the next amount of miles is equal to whatever we have now plus 300, but knowing that we started at 0 miles. Part B asks us to write the equation, or what equation tells the number of miles the plane is from Chicago, y, after x hours. So this one is telling us in x's and y's. So y is the number of miles. Y equals, and we want to do slope-intercept form. So our rate of change was 300 miles per hour. So we would have y equals 300x, and then our starting distance was 0. So our starting coordinate was at 0. So we would have plus 0, which in this case, we don't have to put anything. So y equals 300x. Because, again, this was the distance, the number of miles. What is the number of miles we started at? 0 miles. This was writing now-next rules, and using the now-next rules to create our equation is also helpful. If you notice, the now-next rule in example 8 have the same numbers that the equation does, and the now-next rule in example 9 have the same numbers that the equation does. It tells you your rate of change and also your y-intercept value. On example 10, this one is using a scenario and a graph. So it says the graph shows the total cost in dollars of buying D donuts. We can see that the donuts is your x-axis, so that is the independent, and the total cost is your y-axis, which is the dependent. A asks us to find and interpret the slope. Slope is our m, which is our rate of change, which is change in y over change in x. What we're looking at on this graph here is we need to find two clean coordinates. Our first clean coordinate would be at 0, 0. So 0 donuts cost $0, which makes sense. Our next clean coordinate would be at 4 donuts cost $5. Another clean coordinate would be at 8 donuts cost $10. So what is our slope? Our change in y would be from this first coordinate going to this location, so I could go across, would be a positive y, or a positive, change in y is positive 5. So we'd have plus $5. Always using our units. Divided by, our change in x is going to go to the right, 4 donuts. So change in x is positive 4. But that is plus 4 donuts. So if we were to simplify this, our slope is going to be $1 per donut. Slope is going to be $1.25 per donut. Using our units, money per donut. So to interpret this, it means that each donut costs $1.25. That's the interpretation of our slope. Next, it asks us to write the function rule equation that gives total cost after donuts D have been bought. As a reminder, total cost is your y and donuts is your x. We will be using the correct variables, however. So big C here is our y. So y equals mx plus b. We would have C equals, for our y, mx, that's going to be our slope. Our slope was $1.25, 1.25. Again, it was mx. Our x variable is little d for donuts, plus our y-intercept value. Well, our y-intercept value is at 0, which makes sense because 0 donuts should cost $0. So I would have plus nothing. Or you could also keep it as the slope of a simplified fraction. It could be C equals 5/4D, because that would be the simplified fraction of 5/4 without it being the unit rate. And we use 5/4 so that we can see the change in y is 5, the change in x is 4. Both answers are correct. One of them helps you to be able to graph it, and one helps you to understand the context. Question C says, the bakery gives a $2 discount if you buy a dozen. How much will you end up spending if you buy 12 donuts after the discount? Using our equation here, we know that the cost is equal to $1.25 times the amount of donuts you're buying. If we buy 12 donuts, we're going to plug in 12 for our donuts, for D. Again, you can use the 5/4 or the 1.25. If I were to simplify this, we would get that cost is equal to $15. However, this is before the discount. So now we have to use the discount. The discount said that from the $15, that if you bought 12, you would get a $2 discount. So $15 minus $2 would be $13. This means that you would spend $13 after the discount. So it's not just finding the original answer, but remembering to interpret or to read back through what all you have to do. It gave a discount after you bought the 12 donuts. So you had to figure out what the price was with the 12 donuts. Then we had to do the discount. So we had to subtract the $2 from the original price.